Hello Year 10. Today we're going to look at how do I multiply and divide using index laws. First of all, I'd like you to have a go at the do now questions on the board. The top section recapping what we did last lesson, and then the next two questions recapping the previous unit on lowest common multiple and highest common factor. Pause the video, have a go, and then press play when you're ready for the solution. Okay, 6 squared is 6 multiplied by 6, which is 36. 12 squared is 12 multiplied by 12, which is 144. Negative 7 squared is negative 7 multiplied by negative 7, which is 49. And negative 3 squared is negative 3 multiplied by negative 3, which is 9. Square root of 25 is 5. The square root of 100 is 10. The square root of 16 is 4, but we've got a negative before that, so that would be negative 4. Remember, we couldn't square root negative 16, but we can square root 16 and put a negative before it. Square root of 36 is 6, so this becomes negative 6. 10 squared is 100, and the cube root of 27 is 3. 100 plus 3 is 103. 13 squared is 169. The cube root of 216 is 6, and 169 plus 6 is 175. Negative 14 squared is 196, and the cube root of 64 is 4. The sum of those two things is 200. Negative 3 squared is 9, and the cube root of 125 is 5. The sum of 9 and 5 is 14. Okay, next section, find the lowest common multiple of 24 and 36. Now for this one, you can either do Venn diagram or list them. I'm going to list for these 24, 48, 72, and 36 and 72. So the lowest common multiple is 72. For this question here, find the highest common factor of 3,780 and 3,240. Give your answer as a product of prime factors. Now, because these are such large numbers, we're much better off doing a Venn diagram. And to find the highest common factor, well, they've already written each number as a product of its prime factors, and we put the common prime factors in the crossover part of the Venn diagram. So if we look at the 2s, there's a 2 squared and a 2 cubed, so the highest common factor would be 2 squared there. We've got 3 cubed and 3 to the power 4, so the highest common factor would be 3 cubed. We've got a 5 in both, so we'll put 5 in. And then there's a 7 over here. And an extra 2 and an extra 3 over here. So for the highest common factor, I'm just going to multiply these bits together. So the highest common factor as a product of prime factors would be 2 squared multiplied by 3 cubed multiplied by 5. There we go. Hopefully you've got all of those recap questions correct. Now we're going to start today's lesson. True or false? I've got a number of questions here and I want you to decide if they're true or false. First question is x squared multiplied by x cubed is x to the power of 6. Now, because this is a new topic, I'm going to give you a bit of a clue here. We would write x squared as x multiplied by x. We would write x cubed as x multiplied by x multiplied by x. So if I multiply x squared with x cubed, does that give me x to the power of 6? No. We've got 5 x's here, so that would give me x to the power of 5. I'm not going to write this out for all of them, but have a think. X to the power of 4 multiplied by x to the power of 5. That would be false. We don't multiply the powers, which has happened in the first and second question. X to the power of 3 multiplied by x to the power of 6. That would be true. X, which in other words is x to the power of 1, but we don't write the 1, multiplied by x to the power of 7 is false. What do you think the correct answer should be? X to the power of 5 multiplied by x, or in other words multiplied by x to the power of 1, is x to the power of 6, and that's true. So looking at this, can you think of a relationship here? Can you think of a rule? The rule is x to the power of a multiplied by x to the power of b. Look at the ones that are true. What do we do to the powers? We add them. So that's x to the power of a plus b. Write that rule down if you like. Let's have a look at a worked example. Now, this only works when the base numbers are the same. So the base numbers here are 4. In the previous examples, they were x. We couldn't, for example, simplify x to the power of 3 multiplied by 4 to the power of 5, or 3 to the power of 3 multiplied by 4 to the power of 5. That wouldn't work because they have different bases. So here, 4 to the power of 3 multiplied by 4 to the power of 5 gives us 4. The base stays the same. We add the powers. 5 plus 3 is 8. You guys have a go at this one. 4 to the power of 6 multiplied by 4 to the power of 2 would give you 4 to the power of 8. Have a go at these quick fire questions. Add the powers. Don't do this. This is a reasonably common mistake. Don't multiply the actual 4s. Don't do 4 times 4 is 16, because that will give you a different base, and we want the base to remain the same. P to the 6 multiplied by P to the 9. 9 plus 6 is 15. So we've got negative power, but we're still doing the same thing. We're still adding. 3 plus negative 2 is 1, which gives us 5 to the power of 1, which we just write as 5. Okay, have a go at these questions. Here are your answers. Now hopefully you got most of those correct. I'll go back to questions 10 and 11 and maybe go through those because they're a little bit more tricky. But just make sure you're checking your answers to these ones up here. Okay, 27 multiplied by 3 to the power of 5. Now 27 can be written as 3 cubed, and 3 to the power of 3 multiplied by 3 to the power of 5 is 3 to the power of 8. Okay, that's giving you a clue of how to answer B and C. So for B, 4 cubed, now 64 is actually a power of 4. It's the same as 4 cubed. Then we can add the powers because we have the same base, 4 to the power of 6. See, we've got 5, which is the same as 5 to the power of 1, and 125, which is the same as 5 cubed. Then we can add the powers, 1 plus 3, that gives us 5 to the power of 4. Okay, moving on, we're going to try another true or false. Again, I'm going to show you the long way so that you understand it, and hopefully you can decide if this is true or false. If I had x to the power of, I'm going to do the second one because it means I have to write out less x's. X to the power of 6, so x multiplied by x, multiplied by x, 3 more x's. Excuse my writing, it's hard writing with this math. So x to the power of 6 divided by x to the power of 3, so all over x to the power of 3. Would that give us x to the power of 3? well. We cancel out an x, cancel out another x, and cancel out another x, and we're left with x multiplied by x multiplied by x, which is x to the power of 3. What do you think we're doing to the powers when we divide? Do you think the first answer is correct? No, that's false. The second one we've shown is true. Do you think this one's correct? Yes, that one's true. False. And the last one is true. What do you think the rule is? The rule is x to the power of a divided by x to the power of b equals x to the power of a minus b. So you can see on the ones that are true, we're subtracting the powers. 6 minus 3 is 3, 27 take away 3 is 24, and 4 take away 4 is 0. Okay, using that rule, 3 to the power of 5 divided by 3 squared is equal to 3 cubed. You have a go at this one. 3 to the power of 7 divided by 3 to the power of 5. 7 minus 5 is 2. Some quick fire questions. 4 to the power of 10 divided by 4 to the power of 2, 4 to the power of 8. 3 to the power of 6, this line means divide. Divided by 3 to the power of 3, which gives us 3 to the power of 3. Okay, 5 squared multiplied by 5 to the 4 would be 5 to the 6. And then divide by 5 squared, which gives us 5 to the 4. Okay, add the powers on the top, add the powers on the bottom. Negative 1.5 plus negative 3.5 would be negative 5. And then we're subtracting the powers 8 minus negative 5, which is the same as 8 plus 5. So that would give us 3 to the power of 13. Okay, you guys have a go at these. Then play the video and I will show you the answers. Here we go. How did you get on? Did you get all of those correct? Now have a go at these more challenging questions and we'll go through the answers together. Here are the answers to those questions. If you've got them all correct, you can end the video now. If you made any mistakes, just listen on to the next part of the video where I'll go through the answers. Okay, 9 to the power of 6 divided by 9 to the power of 8 is 9 to the power of 4, so that must be 2, because 6 take away 2 is 4. This must be 5 minus a. Oh, no, we're working out a, excuse me. So that's power 1, and 5 minus what gives us 1? A must be equal to 4. 6 minus what gives us 9? It's going to have to be a negative 3. Because if I subtract negative 3, it's the same as adding 3, and that gives me 7 to the power of 9. You multiply 3 powers of 9 together. She gets 9 to the power of 12. If they were all different powers, what could they be? Well, any numbers that add to 12, so for example 1, 2, and 9, or any other 3 numbers that add to 12. What if all 3 powers are the same? Well, 12 divided by 3 is 4, so there'd have to be 4. 4, 4, and 4. That adds to 12. Harvey divides 2 powers of 5. 5 to the power of something divided by 5 to the power of something gives us 5 to the power of 6. What could they be if both numbers were greater than 20? It could be 5 to the 27 and 5 to the 21, but there are lots of different answers here. The power of one number is double the power of the other number. So we could have 5 to the power of 12 and 5 to the power of 6, because 12 minus 6 is 6. Okay, multiplying here, 3 plus 7 is 10, take away 4 is 6, 3 minus 2 is 1, plus 7 is 8, 4 plus 3 is 7, take away 5 is 2, and 2 plus 6 is 8, take away 7 is 1, which is the same as just writing 8. Okay, excellent. Hopefully you found that lesson relatively straightforward. If you didn't, please come and see me or any of your teachers or go online to revise. Well done for getting to the end of that video.